Okay, so in this video, we are going to extend our portfolio theory to more realistic case. So in the previous video, I explained as if you are buying one stock of A and another stock of B, but that's unrealistic. So it is more like allocation with weights, right? So when you have $100, you spend invest $30 on A and $70 on B. That is more realistic portfolio decision. So we are going to now define X in that way. X is 30% of A and 70% of B, right? They are added. Then we are going to study, our main focus is on the risk in X, this portfolio, right? So to calculate the risk, the standard deviation of X, we need to use all the formulas we have learned so far. So first formula is the linear transformation of variance, right? So it's like 0.3 times A is a linear transformation of A. And 0.7 times B is another linear transformation of B. And covariance of linear transformations, right? And finally, variance of two random variables, sum of two random variables. So one and another, they are connected by summation. So we have to combine all three formulas to calculate, to derive the general formula for X. Okay? So first, X is sum of two parts, 30% of A plus 70% of B. So treating each of them as a random variable, so you may write the variance of X as variance of the first part plus variance of the second part plus 2 times covariance between them. That is what we are going to get using the third equation. And we will derive each of them using the first two equations. So variance of 0.3 times A. 0.3 times A is a linear transformation. So 0.3 is squared and multiplied to variance of A. And 0.7 B is similar. 0.7 squared variance of A. And then the covariance of linear transformation of A, linear transformation of B equals 0.3 times 0.7 times the original covariance. So we did this in the previous chapters. So combining all of them, we have a very complicated result. So variance of a weighted portfolio is the first weight squared times the variance of the first asset plus second weight squared times the variance of the second asset plus 2 times the first weight times second weight times the covariance. That is the full portfolio variance. Okay, so you don't need to memorize it. It is just combining all the formulas, all the properties we have learned up to this point. And this is a generalization. So instead of 30%, you put W, and 70% is 1 minus 30%, so 1 minus W. Okay, so then you can simplify the formula in this way with two assets. Of course, so you may extend it to multiple assets and more complicated cases, but we will simply consider two asset case. And this is the simplest possible example in optimal portfolio theory in finance, right? Of course, there are more complicated things to consider, but it is just a statistics course, so we will use a simple example. We are going to use real data. We are going to use real data from 86 through 2016 from Yahoo, and I chose 4 major companies. You know, in the past, maybe in the 80s, ExxonMobil was the #1 company in the stock market, biggest what do we say, capital, and then Walmart, and then Microsoft and Apple these days, you know, right? So I give you the covariance matrix. This is covariance matrix, and as you see, Exxon is very least risky asset among these four. Apple has the highest risk among these four. Okay, and the covariances are all positive. All positive, pretty much similar. Exxon and so maybe so let me put it this way. So Exxon covariance with Walmart, Microsoft, Apple are similar, and Walmart also has similar covariance with Microsoft and Apple. And you know what? All the assets have positive relationship. And among these four, I will specifically interested in investing 50% of my asset on Exxon and 50% on Apple. Let's calculate that risk, the risk of this portfolio. So keep this in mind. Exxon has a variance of 8.3 and Apple's variance is 38. So I am investing on the safest and the riskiest assets at the same time, half and half. And let's see where the final variance will be. So this is what we have: 50% Exxon, 50% Apple. Okay, applying what we just derived, first weight times the first weight squared and variance of Exxon plus Apple weight squared, variance of Apple, and 2 times weight covariance. Plug in the variance covariance. So we take this number and this number, this number and this number and this number. So variance of Exxon, variance of Apple, covariance between them. And you get 13.11. So review this. So when you invest 50-50 on Exxon and Apple, the final variance is closer to the lower side. So you are diversifying, reducing the risk a lot. So Apple has a huge risk, but you are lowering the risk by also investing on Exxon. So then I will have you do this. How about what if you invest more on Exxon? So invest 80% on Exxon and 20% on Apple, and find the variance of the portfolio. So you will need time. So use calculator, Excel, and calculate the variance. Use this similar formula like this. Instead of a 50-50, you have to use 80% and 20%. Stop the video here. Okay, I'm going to resume. So everything the same, 80% squared, 20% squared, 80-20 covariance, and variance covariance. Plug them in, and then surprisingly, you get 7.6 as the variance. Why is it surprising? Because 7.6 is even lower than Exxon itself, right? So, like, if you are if you would like to minimize the risk, then the answer is not just buying the safest asset, right? So I would like to minimize the variance, so I buy safest asset. No, that is not right. The correct answer is you have to find the right combination. The optimal combination may achieve even lower variance, like this. So this is surprising. You can achieve even lower variance by buying risky asset, even if the risky asset is positively correlated with Exxon, right? Still, diversification will reduce your variance. So this is a very surprising result in finance, right? So if in case if you are investing, so think about this and think about your investment. So by the way, in doing this, I'm talking only about the variance. You also need to think about expected return, right? Like high risk, high return is in general truth, but if we ignore like expected return, then only in terms of variance, diversification is king. Okay. Finally, once more, when I say positive correlation, I'm only thinking about linear relationship. I do not worry about this kind of, I do not think about nonlinear relationship like this. So among these stocks, there may be nonlinear relationship, but I cannot handle that within our framework. So our framework is limited in that sense. So you should be careful if there is any nonlinear relationship. Okay, thank you for watching. This is the end of chapter 11. So I hope you enjoyed it. So next chapter will be the last one this semester. So and the most important one in this semester. Okay, see you there. Have a nice week.